Hello everyone, welcome back to Pre-Algebra with Miss Betsy. We're finishing up at Chapter 3. We're talking about decimals. Specifically today we're on Section 3.8 in our text, which is Pre-Algebra for Christian Schools by Bob Jones University Press. And this is where we're going to be solving decimal equations using multiplication and division. Nothing really new here except the fact that instead of multiplying and dividing by whole numbers, you're going to be multiplying and dividing by decimal numbers to solve the equation and find the value of the variable. But before we get started, I've got a couple of lame jokes for you. Thought this was perfect. Where does a math student eat his lunch? At the multiplication table. What has four wheels and flies? A garbage truck. Which is a very ancient one, but it's still every bit as lame now as it was 35 years ago when I heard it. So we are on page 100 in our text, solving decimal equations using multiplication and divisions. You solve these exactly the same way that you solve equations involving whole numbers. We've been using the principle of a seesaw or a balance beam or a balance scale that says with the equal sign in the middle, our equation's in balance. And as long as you do the same thing to both sides of the equation, both sides of the seesaw, if you have a seesaw that's balanced and you add 20 pounds on one side, it's going to be out of balance until you add 20 pounds on the other side. Then it's back in balance. The weight on either side is different than it was initially, but because you've done the same thing to both sides of that seesaw, it's still in balance. Whether you add something to it, take something from it, in the case of equations, whether you multiply both sides by something, whether you divide both sides by the same quantity, as long as what you do to one side of the equation, you do to the other side of the equation, your equation remains in balance. So let's say that we have example 1 here. This says solve 1.6x is equal to 152, and then it tells us to check the answer. And what are we going to do here? First, we're going to remember that when they say solve, you can only solve something when there's an equal sign here. And what we're going to do is find the value of the variable. Our original equation here tells us that 1.6x is equal to 152. Well, that's all fine and good, but we don't care about 1.6x. We only want to figure out what the value of 1x is. Then we talk about when we solve an equation for x, what we are doing is called isolating the variable. Oh, I saw a text the other day. It said, "Dear Math, please stop asking me to find your x. He is never coming back. Goodbye." So, we're isolating the variable. We want to get x all by itself. And we do this by using the principle of inverse operations. And you remember that inverse operations undo one another. If I start out with no money in my hand, I add $5 to my hand, I subtract then I take that $5 back. Do I have any change? Do I have any money here in my hand? No, I really don't. No money. I've got $1, somebody added $1. I subtract that $1, I still have no money. The inverse operations undo each other. You add something, take that same value away to subtract it, you have no change, no net change in what's going on. Same thing if I start with the number 2, and then I multiply it by 2, and I end up with 4. But then I divide that 4 by 2 again, and I end up with 2, which is the same number that I began with. So just like addition and subtraction are inverse operations that undo one another, so also multiplication and division undo each other. We started with the number 2, multiplied that by 2 to get 4, divided that by the same number 2, and I'm right back at my original number. So when you are solving equations, isolating the variables, you're looking and saying, What operation was performed on that variable? What did we do? Is this 1.6 plus x, 1.6 minus x, 1.6 divided by x? 1.6 times x. Times is multiplication. The inverse operation to that is division. So here we've multiplied 1.6x. We've multiplied x by 1.6. We're going to divide by 1.6. That's going to get us back to x all by itself. Our equation's not in balance though anymore because we have performed an operation on this left-hand side here, but we haven't done anything on the right, so it's out of balance. Now, as long as we divide the right-hand side of the equation by 1.6, our equation's happy, it's in balance. Looks different now, but relatively speaking, in relationship left side to right side, still in balance. We learned that any number divided by itself is 1. You can cancel common factors. So you have x is equal to 152 divided by 1.6. What we're doing now, on your homework paper, you have written a line, drawn a line right down that middle to show your work or to show your scratch. What you have is 152 divided by 1.6. We're going to do that long division, but first, we're only going to divide by a whole number. We have 1.6 here. How do we make this a whole number? In our last video, we said, remember, move that decimal point one place to the right. Well, in this case, we move it one place to the right. What we're doing is moving it clear to the furthest most right position necessary to give us a whole number. 1.6, move the decimal point to the right, and it becomes 16 as a whole number. We have moved our decimal point one place to the right. In the divisor, we have to move it one place to the right in the dividend also, which means we have to add this extra 0 in here. And now we can move our decimal point up one floor so we have it in the proper location. 16 goes into 15, you can't do it. Let me go ahead and rewrite this here so it doesn't look so messy. 1, 5, 2, 0. Make sure that you understand that 152 divided by 1.6, when you finish moving the decimal points around, becomes 16 divided into 1520. Now, since we couldn't get 16 into 15, I'm thinking that's going to be awfully close to 9. Okay? What's 9 times 16? Well, maybe I don't feel like doing that in my head, or I'm not real sure about that. 6 9s are 54. Carry 5. 9 times 1 is 9 plus 5. 144. And yes, 9 is what we're looking for here. 9 times 16 is 144. We're going to subtract. We have 8. 144 plus 8 is 152. We bring down a 0. And it becomes a 0. It does not turn into a 6. 5 times 16 is 80. And that's where we had our decimal point located. So according to our division, 152 divided by 1.6 is going to be equal to 95. Now, how are we going to check this? Now, don't fall into the trap of saying 95 times 16 is 1,520. Because we have to remember that what our original problem was, and don't erase that on your work, just leave it there. The only reason I'm erasing it is so that you can see on the board what I'm doing. We're saying 152 divided by 1.6 is 95. So our check shows us going 95 times 1.6. 6 times 5 is 30. We carry 3. 6 nines are 54. 57. 0. 2. 5. 1. Look in there. Can't tell for sure, but this shows 1,520 right down here. But we have to locate our decimal point correctly, one space. So we see that 95 times 1.6 is equal to 152. So our answer is correct, and we have checked it. There is 95. Another way to show your check, rather than write it over here in the scratch column like I did, is you could do exactly this. You solved your problem, you said that x is equal to 95, and then right underneath it you can simply write check. And you can say 95 times 1.6. 5 sixes are 30, 54, 57, 5, 9, 0, 2. 15, 20. We see that we have one decimal point. We locate our decimal point correctly, and our problem is checked. 95 is the quotient that we get when we divide 152 by 1.6. Okay? Let's go ahead and do one more of these. This was a division problem. If you're multiplying x by a decimal number, you divide both sides by a decimal number. Now we're going to do one where we have divided the variable by a decimal number. And this says solve x divided by 0.45 is equal to 8. X divided by 0.45 is equal to 8. Now let's make sure that I've copied this correctly. X divided by 0.45 is equal to 8. Check the answer. This is a two-part problem. If you have this on a test, it says solve the equation, check the answer, and you don't check the answer, it's -1/2, even if you've gotten the answer correct. That's because you haven't followed the directions, you haven't done what they've asked you to do. So, we have x divided by 0.45 is equal to 8. What's going on here? The variable has been divided by a decimal number. The inverse operation to division is multiplication. So we want to multiply that variable by the same decimal number. Our equation is now out of balance. It had been in balance. We multiplied one side, but did nothing to this side over here. We have to multiply the right-hand side of the equation by that same number. 0.45 cancels. You have x is equal to, here's my scratch work, 8 times 0.45, 5 eighths are 40, 4 eighths are 32, and 4 is 36. Where does our decimal point go? We have two places to the right of the decimal point. We're going to have to locate that decimal point two places so that there are two places to the right of it. 3.60, you drop that 0, x is equal to 3 6/10. Are we finished? No, we're not finished because our instructions tell us check the answer. How do you check the answer? Right here. What divided by 0.45 is equal to 8? We're saying that 3.6 divided by 0.45 is 8. We have to check it using long division. 3 6/10 divided by 0.45. How do we do decimal division? You have to move the decimal point in the divisor so that you are dividing by a whole number. In this case, we have to move our decimal point two places to the right so that we end up dividing by a whole number, which means we have to move our decimal point two places to the right here, which requires us to insert that 0 as a placeholder. So what we're actually, the actual mechanics of what we're doing here, we're saying that we're going to divide 360 by 45. So here's our check. 360 divided by 45. How about 9? Well, 4 times 9 is 36, so that's too big. Let's see what happens when I get 8. Since we know the answer is supposed to be 8, it'd be a good thing to try. What is 8 times 5? Or if you need to do this over here, 8 times 45, 5 8s are 40, carry 4, 32 and 4 is 360. So we have 360. Our quotient is the same. The answer to the division problem is an 8. We don't have to mess with the decimal points here because we had to manipulate to get whole number division, but we saw last video that your quotient doesn't change when you multiply dividend and divisor by the same number. 8, 8, our answer is correct. That is the end of section 3.8, the end of chapter 3. You guys can go ahead and keep working on this. I know you're going to do great, and I will see you next time.